Dear all, welcome to the another video of our course, that is discrete mathematics. And from our few videos we have seen the types of relations, and in our previous video I have discussed about the symmetric relations. And if you haven't watched this video till now, you can watch it from my playlist. And today we are going to start the another type of relation, that is a symmetric relation. So as before defining the asymmetric relation, I would like to give you the example which help you to understand the concept of a symmetric relation in better way. So we have a set A which contain three elements A, B and C, and this is the matrix representation of cross product. And this is the matrix representations of cross product, and I have colored the symmetric pair using same color. Here BA is the symmetric of AB, CA is symmetric of AC, and CB is symmetric of BC. And in symmetric pairs we have seen that these diagonals elements are symmetry of itself itself. So in asymmetric relations, if we include BA, then we don't need to include AC. If we include CA, then we don't need to include AC. So if one of the symmetric elements are there, then we don't need to include the symmetric pair of that element. Here in R1 we have BA, and another element is in R1 we have AB, and the another element is BA. So AB is symmetry of BA. Therefore, this relation is not an asymmetric relation. So we have another relation R. Here we have AB, and we don't have a symmetric pair, that is BA, in this relation R. We have BC. We don't have its symmetric elements of BC, that is CA. CB, and similarly we have CA, and we don't have the symmetric pair of CA, that is symmetric pair of CA is AC. So here in relation R we don't have any symmetric pairs. Therefore this relation R, second relation R, is a symmetric relation. In a symmetric relation we don't need to include both diagonal elements, and both symmetric element as well as diagonal elements. So we don't need to include diagonal elements and the both symmetric elements. If we have one symmetric elements, then we don't need to include another symmetric elements for that relations. If we contain both the symmetric element, then the relation is not a symmetric relation. So a relation on set A is said to be asymmetric if AB belongs to R, then BA does not belongs to R. I am going to give you more example of asymmetric relation which will help you to understand the concept of asymmetric relation in better way. So we have set A, and this is the matrix representation of A cross A, and these are the elements of cross product. Now we need to identify which of the relation is asymmetric. So here in R1 we have AB, and we have another element, that is BA. So this AB and BA is symmetry of itself. So this relation contains the symmetric pair. Therefore the relation R is not a symmetric relation because we have symmetry pairs here. So we have another relation, that is R2, and we have the first element, that is BA, and we have here AB, and we have here BA. So these two is symmetry of itself. Symmetry of itself. Therefore, this relation R2 is also not a symmetric relation because it contains symmetric pairs. Here BA, so here BC is symmetry of CA and AA. So we also don't need to include these diagonal elements because the diagonal elements is also a symmetric with itself. So this relation R2 is not a symmetric relation. Here we have another relation. So first let me erase the content whatever I have written just now. So first I am going to erase this. So here in R3, here in R3 we have AA. So this is the diagonal pair. So in a symmetric relation we don't need to include this diagonal elements, and we have BB. So it is, so we don't need to include this element. So by checking the first condition we can say that this relation is not a symmetric relation because it contains diagonals element. And here we have R4. We can, first element of R4 is AB. So we have, so symmetric of AB is BA. So symmetric of AB is BA. So we don't have BA in this relation. So it's okay. Then we have BC. Symmetric of BC is CB. So we don't have CB in this relation R4, and the symmetric of this CA is A and C. So we don't have AC here. Therefore, this relation R4 is a symmetric relation. And okay, so and we have another relation. So we have another relation R5 which does not contain any elements. Therefore, it does not contain any symmetric pairs. Therefore, this relation R5 is a symmetric relation. Now we have another R5. So this is R6. So we have A cross A. So A cross A contain this all element AA, AB, BA, BB. Therefore, this R5 is also not a symmetric relation. So among these relation only R4 satisfy the condition of a symmetric relation because it does not contain any symmetric pairs as well as diagonals element. So the relation is said to be a asymmetric relation if it does not contain the diagonals elements and the both symmetry pair. So only one symmetry pairs is allowed in the asymmetric relation. So this is all for asymmetric relation. Now we are going to see the another type of relation, that is antisymmetric relation. In antisymmetric relation we can include this diagonal element, we can include these diagonal elements but not both symmetric pairs. So it is just like a symmetric relation, but here we can include the diagonal element, but in a symmetric relation we can't include this diagonal element. So in antisymmetric we can allow the diagonal elements but not a symmetry pair. So here relation R is a symmetric relation, sorry, antisymmetric relation, because it contains AB and AA. So AA is symmetry of itself, but in antisymmetry these diagonal elements will allow, but these symmetry elements is not allowed. So here AB and AA. So we allow these diagonal elements and we don't have the symmetry pair for AB. Therefore, this relation R is anti-symmetric. So a relation on set A is said to be a symmetric relation if AB belongs to R and BA is also belongs to R. Therefore, AB must equals to BA. That means we allow the diagonal pair, because when AA is equals to A, that means it can define in simple way. So this is how we can say that AA is equals to AA. So this antisymmetric relation is nothing but the relation where we allow the diagonals element but not a symmetric elements. So we can allow this diagonal elements in a relations but we don't allow these both symmetric elements. If we include these symmetric elements, then we don't need to include this element. If we allow this CA, so we don't need to allow this AC. So if we allow BC, then we don't need to include CB, and we can allow this diagonal pair. So this is all for antisymmetric. Now we are going to see the few example of antisymmetric relation. So we have set A, which contain 3 elements AB, and this is the matrix representation of A cross A. So we have first relation, that is AB, and symmetry of AB is BA. So BA, so we have BA. So we don't allow these symmetry elements. Therefore, this is not a anti-symmetric relation. So we have another relation. So this first relation is not a anti-symmetric relation, and we have first element which is AB, and the symmetry of AB is BA. So we don't need to check further because we have this symmetry pair. So this is not a anti-symmetric relation. So here we have another relation which contain all the diagonals elements. In anti-symmetric relation, we can allow diagonals element. Therefore, this relation is anti-symmetric and as well as asymmetric as well as anti-symmetric, asymmetric, and symmetric as well. Because in anti-symmetric, symmetry and anti-symmetry. In anti-symmetry, we allow these diagonal elements, and we have another relation, that is BA. So symmetry pairs of AB is BA. So we don't have BA in this relation. R4, the symmetry of this BC is CB. So we don't have CB in this relation, and the symmetry of CA is A and C. So we don't have AC here. So therefore this relation is anti-symmetric. And now we have another relation. So we have another relation R5 which doesn't contain any element. Therefore this relation is also a anti-symmetric relations. And we have A cross A. So this relation is not an anti-symmetric relation because we allow both symmetry pair in A cross A. Therefore, this relation is not a anti-symmetric relation. In anti-symmetric relation, we don't allow these symmetric pairs. If one of the symmetric pairs are there in a relation, then we don't need to have this another symmetric pair. But in a symmetric relation, anti-symmetric relation, we allow these diagonals element. So this all for today's lecture. See you in next video. Thank you.